Empirical and molecular formulas. What are they and how do we use them? The molecular formula is a formula that describes the exact actual number and type of atoms in a single molecule of a compound. It uses chemical symbols and their exact amount as numbers and subscripts. The molecular formula cannot always be determined from the empirical formula. The empirical formula is the molecular formula reduced to the lowest common denominator. The empirical formula can always be determined from the molecular formula. The molecular formula simply states what there is. For example, take a person with 2 hands and 10 fingers. The molecular formula for this would be H2F10. H stands for hands, F stands for fingers. The empirical formula can always be determined from the molecular formula. It shows what there is in a simplified version. The molecular formula of H2F10 can be simplified by dividing the subscripts by 2. The empirical formula would be HF5 because the proportion of fingers to hands is 5:1. It is important to remember that more than one substance can be reduced to the same empirical formula. To stretch the hand analogy, there could be a person from the first example, or there could be an alien with 3 hands and 15 fingers, H3F15. Both of these would be reduced to the same empirical formula of HF5, since in both cases the proportion is 5 fingers for each hand. Let's look at an example of determining the empirical formula from percent composition. If there is a compound with a percent composition of 54.52% carbon, 9.17% hydrogen, and 36.31% oxygen, determine the empirical formula. Step 1. Assume you have a 100-gram sample. That would mean you have 54.52 grams of carbon, 9.17 grams of hydrogen, and 36.31 grams of oxygen. Step 2. Convert grams to moles using molar mass. Remember that you can look at the molar mass by looking at the periodic table. That would give you 4.54 moles of carbon, 9.08 moles of hydrogen, 2.27 moles of oxygen. Step 3. Divide all by the smallest number of moles to find the smallest whole number ratio. That would give you 2 moles of carbon, 4 moles of hydrogen, and 1 mole of oxygen, because you would divide all of them by 2.27. Step 4. Check to see that you have a whole number ratio. If not, multiply the ratio to obtain the smallest whole number ratio. For example, if one of the numbers was 0.5, then you would multiply all of them by 2. The empirical formula for this example would be C2H4O. But what if you're asked to determine the molecular formula? Step 5. Determine the molecular formula using the given molecular weight and the previously determined empirical formula. If the molecular weight for this unknown compound was 88.1 AMU, that could be compared to the molecular weight of the empirical formula, C2H4O. You would find the molecular weight for each of the elements, and it would add to give you 44.06 AMUs. Because the molecular weight of the unknown compound is twice the molecular weight of the empirical formula, the molecular formula must be twice that of the empirical formula. Step 6 would be multiplying the empirical formula by 2 to get C4H8O2 for the molecular formula, which would equal 88.12 AMUs. Some main points to remember are that molecular formulas tell you how many atoms of each element are in a compound. Empirical formulas tell you the simplest or most reduced ratio of elements in a compound. If a compound's molecular formula cannot be reduced anymore, then the empirical formula is the same as the molecular formula. That's the end.